humidity, a topic we all know and have a love-hate relationship with. So what is humidity? I mean, we all walk out and we're like, oh, it's so humid, right? But what actually is it? It's actually the amount of water vapor in the air. I love these numbers because they make you sound really annoying. Did you know that the amount of water in the air is only 0.1 to 4%? That's it. So next time someone's like, oh, it's so humid, you can be like, hey, yeah, I know, it's 4% water vapor in the air right now. They'll look at you like you're crazy, and then you might want to duck because they might punch you. But this 4% is probably the most important gas in the atmosphere, right? Because without it, you wouldn't have clouds, you wouldn't have rain, you wouldn't have snow, you wouldn't have hail. I could probably do without hail and snow, that's why I live in Florida. But we wouldn't have rain or clouds, and in Florida, pretty much clouds is the only shade we get from the sun, so kind of an important piece. There's different ways that we measure humidity. Absolute humidity, mixing ratio. I know what you're thinking, just hold on. Absolute humidity is the mass of water vapor in a certain volume of air. Okay, so you take a volume of air, so let's say you're sitting in your room right now, right? Listening to me. That is your volume of air. Okay, close off all the windows, close the door, close the vents, close everything. And then you'll be able to separate the water in that air from the air, right? So it's grams, because we're talking mass, to volume. So grams per meter cubed. Now, someone comes in and says, hey, you want a drink of water? And you're like, oh, you just opened my door and you ruined my experiment. Right? So now I have a different volume of air and I have a different water vapor, so I've got to do this all over again. Now imagine trying to do that outside. Right? Super hard. So we don't really use that too often. Mixing ratio is another one. The mass of water vapor in this unit of air compared to the remaining air. Right? So the mass of water in the air versus the mass of the dry air. So again, you're in your room, close the windows, close the doors, seal the cracks, close your vents. Now take all the water vapor and put it on one side of the room, and all the dry air and put it on the other side of the room. And so now you've got grams versus kilograms. So at least you're doing mass versus mass, right? But then again, someone comes in and says, hey, we're going to talk about, you want to come? And you're like, oh my goodness, you just messed up my ratio here. I got to start all over again. And again, try and do this outside. So both of these are really hard to do, and they change really quickly. So we don't use them much. We use relative humidity. But I can't talk about that until we understand what vapor pressure is. So this picture here kind of shows you a little bit. So you've got the water, you've got, quote, dry air, and then, you have your water evaporating and your water condensing. Basically, as you get more water vapor in the air, you're getting a higher vapor pressure. Okay? So vapor pressure is your pressure caused by your water vapor. And you hit saturation at a certain point. Saturation is when, probably right about here, when your evaporation and your condensation are happening at the exact same speed. Right? So it's saturated. I like to think of saturation as when I'm putting my chicken in a brine, right? You know, you do this if you ever cook chicken, you should do this. It's very unhealthy, but it makes it taste so much better. Before you cook the chicken, maybe for a couple hours beforehand, you put chicken in a bowl of water. Now, not just water, you add salt to it. So much so that the water gets saturated with salt. It's called a brine. Where you're stirring, you put salt in, you stir it up, the salt dissolves, right? We've probably all seen that. But you put more in, stir it up, salt dissolves. Put more in, stir it up, salt dissolves. At some point, you're going to put more in, stir it up, the salt's going to sit there. That's saturation. Right? Well, technically that's oversaturation. But right at that point where you just put that one grain of salt, that's the last one that can dissolve, that's saturation. Right? And so we're saying that happens with water vapor. You put so much in that it can't handle any more of that saturation. So humid air actually has a very high vapor pressure. Now, I pulled up a video of vapor pressure and saturation.
What happens when you start studying intermolecular forces and we start making a little bit more of a condensed phase, such as solids and liquids, you start getting all these unique properties of solids and liquids. Liquids have quite a few unique ones: viscosity, surface tension, and one of the more unique ones is vapor pressure. That's a very special case, and that's probably another thing completely. So let's just think about it. If you take water in a container and you allow it to start evaporating, the space above the surface of the water will start getting water molecules. That means it's a gas now, and gases impart pressures. So as that builds up, what's going to happen is these particles floating above the water can go back into the water unless they're whisked away. So if you put a lid on the container, all the particles are trapped, so the water starts going back into the water phase, or I should say the water vapor goes back in. As this happens, you finally reach a state at which the exiting evaporation rate equals the entering condensation rate, and you reach what we call equilibrium. So when those two rates equal, you establish a constant pressure inside your container. That pressure is called the vapor pressure of that liquid. In the case of water, you would say it's the vapor pressure of water. It's an example of what we call dynamic equilibrium, meaning when you look at the thing, you can't tell anything's happening, but in actuality, there are billions and billions of molecules leaving the surface of the water, and there's also billions and billions re-entering, and they are exactly the same rate, so there's no net change, but you have established what we call a vapor pressure. And that's hopefully a little bit more of a handle for you on what vapor pressure is.
We see water vapor in there all the time, right? And specifically, heating causes more evaporation. Well, if more evaporation happens, then that means more water vapor is in the air, so your vapor pressure will rise. Saturation vapor pressure depends on temperature. Saturation vapor pressure depends on temperature. This is a big thing. Saturation vapor pressure depends on temperature. Okay. We're going to dive into that a little bit more, but right now we'll talk about net evaporation and net condensation. So net evaporation is basically a puddle drying. More evaporation than condensation, right? So it's starting to pull that water up and it's not precipitating down, right? So puddle drying. The other end of that is net condensation. More condensation than evaporation. So fog happens. And so here's a picture of fog. Actually, it's called radiation fog, but we'll get into that a little bit later. This was a picture from my backyard, actually. Went early one morning. This is a hospital here, a brand new hospital. And this is down in Castle Rock. You can't see Castle Rock from here. It's over on this end a little bit more. But I like looking at my backyard every so often. I miss Colorado when there was no bugs. Other than that, I'm good in Florida. Okay, so I said there's different ways that we measure humidity, and this is the way that you are most familiar with, relative humidity. So relative humidity is the ratio. So again, something over something else or compared to something else. So the actual water vapor compared to the amount required for saturation. Okay, but I said saturation depends on temperature, right? So the actual water vapor in the air compared to its saturation at that temperature. And then it's given as a percent, mainly because most of the population doesn't like ratios. So they give it to you as a percent. So how can you change your humidity? Well, if you add water vapor to the air, your humidity goes up, because what is relative humidity? It's water vapor in the air compared to saturation at that temperature. So if you add water vapor, your humidity goes up. If you take away water vapor, your humidity goes down. Now, 100% relative humidity means that you are at saturation. It means that that air cannot hold any more water vapor. Okay? And what it does at that point, well, we'll talk about that later. So, relative humidity will increase if you put water vapor into the air. However, what's the other part of it? Saturation at a certain temperature. So it will also increase if your temperature goes down. Okay? Because if your temperature goes down, it doesn't take as much to saturate your water vapor. So therefore, the bottom number gets smaller. Relative humidity will decrease as your temperature increases. This means that the higher you get in temperature, the more water vapor you can hold. So therefore, your humidity will go down. Okay, so this is good news and bad news for us living in Florida, because we always have a high temperature, which means we can hold more water. Right? So if we can hold more water, that means there's more water in the air. Yay! Right? But that also means that as we hold more water, it is likely that our relative humidity will go down. Now, we live in Florida and we know it doesn't. So that means we can hold a lot of water, and we do. That's what that means. Now, daily temperature changes can affect your relative humidity, right? So if you start out with a low temperature, you wake up and it's, I don't know, it's Florida, so we'll go 60, right? It's 60 degrees outside. Your relative humidity should be higher because you can't hold that much water anymore. And then as you heat up, you get to what, 80, 90 degrees, right? And you can hold a lot more, so your relative humidity should go down. So as you go in your afternoon, the humidity should be lower. Now, we know it's Florida, and we can hold a lot of water, and we do hold a lot of water, so that doesn't really happen here.